Hello everyone, welcome to Unit 3, Lesson 1. Today we're going to be talking about sequences, and we're going to introduce the idea of this thing called a sequence. And we initially started talking about this in the warm-up. We saw a sequence in the warm-up, but our goals for the lesson today, we're going to be defining what a sequence is. We're going to learn how to use sequences and function notation to describe a pattern. And then we want to represent a sequence using multiple representations, such as a table, graph, and equations. Right? So let's go ahead and get started here. Let's start with something basic. Like what exactly is a sequence? And it's probably the easiest definition you're going to learn in mathematics. A sequence is simply a list of numbers. So any list of numbers. If I were to make a list of numbers like 1, 1, right, and keep this going. This is a sequence. A random list of numbers could also be a sequence, okay? The list of numbers is not required to have a pattern to be a sequence. However, in math, we are most interested in those sequences that do have patterns, right? So mathematicians love finding, exploring, analyzing, and applying patterns, okay? So what I want you to do is to take a couple minutes and look at the sequences below. And I want you to try to determine the patterns, if any, right? If you think there is a pattern, describe what you think the pattern is, all right? So take a couple minutes, go ahead and do that, pause the video, and see if you can identify the patterns that are happening in these lists of numbers. Okay, so hopefully you've taken a few minutes to take a look at some of these sequences here. So I did the first one here for you. This was the sequence that we saw in the warm-up, and we had described this in words in the warm-up as well. This is the sequence where the numbers are multiplying by 2, right? So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, so forth and so on. So let's take a look at this one. This one is 2, 4, 6, 8. We've seen this sequence before at some point in our lives. This is a list of the even numbers, right? And to generate this one, what we're doing is we are adding 2 each time, right? So we're doing 2 plus 2, which is 4, 4 plus 2, which is 6, 6 plus 2, which is 8. So we would say we are adding by 2. So let's take a look at the next one. This one goes 20, 10, 5. And if we're identifying the pattern in this one, we notice that it is being cut in half each time, right? So if I were to do 20 divided by 2, I'd get 10, then 10 divided by 2, we get 5. Then if we were to continue the sequence, we would continue dividing by 2. So the numbers are dividing by 2. So then let's take a look at this one. This one is kind of unique. So this is 1, 1, 2, 3, 5, 8, 13. And I wouldn't blame you if you had said, I don't think there's a pattern here, Mr. Weldon, but there is actually a pattern. This one's a little bit harder to see, but check this out. If I do 1 plus 1, we get 2, right? So now if I move over a little bit, if I do 1 plus 2, I get 3, right? And then 2 plus 3 gives me 5. And then to get the 8, we do 3 plus 5, right? And then to get the 13, we can do 5 plus 8. So really, to generate this particular sequence, we are adding the 2 previous numbers beforehand. So the next term, right? If I were to generate the next term, I would add the 8 and the 13, which is 21. Then to generate the next term, I would add the 21 and the 13, which would be 34, right? And this would keep on going like this. So here we're adding the 2 previous terms. Some patterns are not as easy to see. And this one is actually, if you recognize this, if you're really into math and famous number sequences here, this particular sequence is known as the Fibonacci sequence, a very famous sequence of numbers that has led to a lot of mathematical discoveries. So, and the pattern is pretty simple. Let's add the 2 previous terms. Okay. This one is just a random list of numbers. I didn't put any pattern into this one when I listed these ones. So this one is just random. Okay. No pattern. So one of the major things you want to be able to do as we go through this unit is to look at a list of numbers or a sequence and try to determine what the pattern is. It's usually step one in any of the problems that we do concerning a sequence. All right, so let's go ahead and move on. We're going to talk about notation now. So there's a couple different notations that we use to describe sequences. So there's what we call the sequence notation and the function notation, but they essentially do the same thing. So informally, what we have is something called a term number, right? So it's like first term, second term, third term, fourth term, right? So it's describing a position somewhere in the sequence. So the first term is 1, the second term is 2, the third term is 4, okay? The fourth term is 8, so forth and so on. So if I wanted to know the fifth term, right, I'd put here a 5, and then I would continue whatever pattern is happening over here with the term values. So there is a distinct difference between the term number and the term value. The term number describes a location in the sequence. The term value gives you the actual values of the numbers in the list, okay? So now formally, the way that we describe these in sequence notation is we call the term number n. Okay, so n is going to be 1, 2, 3, 4, and it describes a location somewhere in the sequence. And then this is pronounced a sub n. Okay, so a sub n. And this is the term value. Okay, so second term is 2, third term is 4, so forth and so on. But instead of saying term number and term value, we say n in a sub n. The other way to describe it is with function notation. This is what we covered in the warm-up. Okay, so very similar. Again, we would define the input of the function to be the term number, right? So we would just call it n, and then the input of the function would be n. Okay, f of n then represents the term value, right? So the first term is still 1, second term is still 2, but the term number is n, and the term value is f of n. All right. So again, the important thing to notice is the difference between term number, okay, so term number and term value, all right? I want to make sure that we can distinguish between what these two are. The term number is a location, the term value is the actual value of the term in the sequence, all right? So let's practice that a little bit. Let's do a couple of exercises here where we kind of use those definitions. So we have a sequence here, again, arranged in a table format. So here we have n and a sub n. So remember, n is the location and a sub n is the value at that location. So this gives us a term number, this gives us a term value. So when we get a question like this, like what is the seventh term of the sequence? So we want to go to the location where the seventh term is, right? So we'd go to n, we would go to 7, and then the seventh term, the value of the seventh term is 64. So the seventh term of the sequence is 64. Okay. So then it says, where does 128 appear in the sequence? Well, this is a term value. Okay. So I'm going to go to a sub n. I'm going to look for 128. Here it is. And it says where, right? So they're asking for the location. Well, it's the 8th term of the sequence. Right? It's the 8th term. Okay. So now we get on here, rather than asking these same questions in English, we want to ask it with mathematical notation. So it says if n equals 5, then what is a sub n? Okay, so we go to n is 5, a sub n is 16. Okay, it's like saying what is the fifth term of the sequence? It's 16. Okay, so now over here, this one says if a sub n equals 8. Remember, a sub n is an actual term value, so 8 should appear in the sequence somewhere. They want to know where, okay? So I'm going to go here. I'm going to go till I see an 8, right? There it is. It's the fourth term in the sequence. So if a sub n equals 8, then n equals 4, indicating it is the fourth term of the sequence. Okay. So let's try it again, this time with function notation, right? So we have n and f of n, right? Term number, term value. Not too complicated here, right? So it says, what is the fourth term of the sequence, right? So remember, the term number is going to be here with n, so we're going to go to 4. So here's 4, and the fourth term of the sequence is 3. Okay, so the fourth term of the sequence is 3. So then it says, where does 55 appear in the sequence? So 55 would be a term value, so I'd go to f of n, and I would scroll across here or scan across. I do not see 55, but remember we talked about this sequence when we were describing patterns. This one would require us to add the previous two terms. So for instance, to get 34, I would add the 13 and the 21. So the next term would be 34 plus 21. So 55 would actually be the next term, which would be term 10. So 55 would appear at the 10th term. Okay. So now again, using more formal notation here, if n equals 4, then f of n equals, well, that's exactly what they asked here, just using the mathematical notation. So if n is 4, then we know f of n is 3. Okay. Then we go here, if f of n equals 55, right? So if the term value is 55, right? Here's 55, then what is n? What is its location? Well, it's 10. It's the 10th term. Okay. So that's how we read that notation. That's how we use that notation to describe where we are at in a sequence or what a value is in a sequence. All right. So now we know about the notation and we know how sequences are displayed in tables. We want to look at how to create equations and graphs for our sequences, right? So we talked about this idea of getting multiple representations to talk about and analyze our sequences. So we're going to talk about graphs and equations next. All right, so we're going to go to the sequence 2, 6, 10, 14, 18. And like I said, usually the first thing that you want to do is just describe what is happening in the sequence, right? Describe it in words. So if I'm looking at this sequence, it looks like it is adding 4 each time, right? So we're adding 4. Right, so 2 plus 4, right? If I add 4 here, 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14. So hopefully you see that pattern there, all right? Now, whenever a sequence is generated by adding, okay, this is important. So if you go into here, if it's going up and down by adding or subtracting what we would call a common difference, right? So if every single time it's adding by the same number, then we can build the equation using this model, okay? So you can kind of see it here. And there's some different pieces here, right? This f of n, we know what that is. That is the term value. So they're saying that the term value can be determined by taking this number d. And this is the common difference here, okay? So essentially whatever you're adding by. So in our case, we're adding by 4, right? So if I wanted to build this equation, I would immediately put a 4 in for d. And then we would do n minus 1. Remember, n is the location, right? It's the term number. Minus 1 plus whatever the first term is, right? F of 1 would be the first term, okay? So you can kind of see here, we can do a sub n, right? So instead of doing function notation, we can use the sequence notation as well. And really the only difference there is replacing f of n with a sub n, all right? So d is the common difference that we're adding by. So for our sequence, right, for this sequence, our common difference, oh, it's not 3, that's a typo. Our common difference is 4, right? So our equation would look like this, right? We would put a 4 in for d, and then we would have this n minus 1, and then you see this plus 2. Well, remember, plus the 2 comes from being the first term of the sequence, okay? So this would be an equation that generates our sequence. So we want to test it and make sure that it works, okay? So let's test our equation. It says, according to our equation, what is f of 2? Okay, so let's test f of 2. F of 2 equals, and so I'm going to go up here. Remember, wherever I see an n, I'm going to put a 2 in. So I got 2 minus 1 plus 2. Okay, so 2 minus 1 is 1, so we've got 4 times 1 plus 2. 4 times 1 is 4 plus 2. So we can say f of 2 equals 6. So this is a fancy way of saying the second term is 6. Well, is it? So let's go back up to our sequence here. Take a look at that list of numbers. Oops, here it is. Here's the first term, here's the second term, and look, the second term is 6. All right, so let's try it again. This time we'll do f of 3. We know f of 3 should be 10. So let's make sure we get 10 with our function, or with our equation. All right, so I'm going to say f of 3 equals 4 times 3 minus 1 plus 2. Okay, so we do the 3 minus 1 first. So that's going to be 2. So we got 4 times 2 plus 2. 4 times 2 is 8. And 8 plus 2 is 10. And that's what we were hoping to get. I'm going to try it one more time just to make sure we've got it. All right, so f of 5. All right, so we're going to do 4 times 5 minus 1 plus 2. Okay, and then we use our order of operations here. So this will be 4 times 4 plus 2, 16 plus 2, and that would be 18. And that is what we wanted to get for f of 5, right? 1, 2, 3, 4, 5. The fifth term is 18, right? So the fifth term is 18. So that question is it generating the sequence correctly? It is. The equation is working. It's calculating the correct term values for the correct term numbers, right? All right, so let's move on. So now let's do a graph. Okay, so we have our sequence here, the 2, 6, 10, 14. We can see first term 2, second term 6, third term 10, so forth and so on. Now to turn a sequence into a graph, we essentially let the term number here, n, right, act as our x, right? So this is kind of like x, right? And then f of n is our y value, right? So input, output, x comma y, and f of n, right? All those things are the same when we go to graph. So this one, right, when we say n is 1, then f of n is 2. That creates an ordered pair, 1, comma 2. So I'm going to go to my graph and I go 1, 2, right? Notice that they're counting up by 2s here, so be careful with the scale. So I would plot a point. All right, then we go to the next one, right? So we got 2, 6. So we're going to go right 2, and we're going to go up 6, plot a point. Then we do 3, 10. So we go up here, 10, and then 4, 14, and then 5, 18. And there we go. Now, important thing here, since this is a sequence, we do not draw a line through these points. This is a what we would call a discrete sequence. In other words, there are no terms in between 1 and 2. So this is not a continuous line. It's only these points. It looks like the points are forming a line, but there's actually nothing in between these points. So we do not connect the dots on sequences, all right? So keep that in mind as we go to like our quizzes and our tests. This is one of those little nitpicky things that I'll take a point off for. So you plot the dots, that's it. If you connect the dots, I will take a point off on your quiz, all right? So try to remember not to do that. All right, so let's do another sequence here. We've got 8, 16, 32. All right, so take a minute. If you need to, pause the video. What is happening in this sequence? What is the pattern? Okay, so hopefully you've got it here. Going from 8 to 16, 16 to 32, hopefully you recognize the pattern here is multiplying by 2. 8 times 2 is 16. 16 times 2 is 32. Okay, now filling in our table is pretty easy, right? The first term, n1, right? So n being 1 means the first term, so that would be 8. The second term is 16. The third term is 32. And then we would just need to continue the sequence on our own using the pattern that we described. So we do 32 times 2 to get 64, and then 64 times 2 to get 128. Right? Now remember, in the previous sequence, we were adding by some number. This time we are multiplying by some number. Okay? And so when we multiply by a number, okay, we can use the following format for our equation here. All right? So this one says ace of 1, this being term 1 of the sequence, times b, and b, okay, is what we call a common ratio. Common ratio. This is what we're multiplying by. All right, so when we say we're multiplying by 2, then we would say that b equals 2 for our sequence. Okay. Now remember our first term, if we go back up and look at our sequence real quick, our first term was 8, right? So this part of the equation, ace of 1, equals 8. So if I'm building my equation, I'm going to say f of n equals, I'm going to put 8 times b, which is 2. So 8 times 2 to the n minus 1. And that n minus 1 is in the exponent. Okay, so this becomes an exponent up here. All right, so this is our equation. And now we just need to create the graph, right? If we have the table, the equation, and the graph, we are complete with our representations. Okay, so we're going to go 1, 8. Right, so we're going to go over 1, up 8, plot a point. Then we're going to go 2, 16, plot a point. Then we go 3, 32. There we go. You notice this one's not really making a line anymore, but remember, don't connect the dots, right? Because this is still a sequence. There's nothing in between these points. The next one would be at 4 and then 64, which would take us way off the graph. So we're not going to plot those last 2 points. The graph is only big enough to fit the first 3. So if you ever run into a graph and it's just not there, like there's not enough room to plot some of the points, just plot the points that will fit. Okay, so there we go. That is a sequence with a multiplier rather than something that we're adding. So now it's your turn. What I want you to do is pause the video, and I want you to try and create the table, the equation, and the graph for these next few problems, and then we'll go over them together. All right, welcome back. So hopefully you gave these problems an attempt. So let's see what we come up with here. So again, the first thing you should do is always just identify the pattern that's going on here. So if I'm looking at this 36 to 30, then 30 to 24, we are subtracting 6 each time, right? 36 minus 6 is 30, 30 minus 6 is 24. And they were nice enough to give us the first 3 terms of the sequence. So this is going to be 36, 30, and 24, right? So term 1, term 2, term 3, and then we could continue the sequence ourselves. So 24 minus 6 is 18, 18 minus 6 is 12, 12 minus 6 is 6, all right? So we've got our table filled out. Now we need to build an equation. Okay, so with this one, right, we had said before, if we have something that was adding, we could use that template or that blueprint that we had before in the previous problem to help us build our equation, but we can use it again here for subtracting as well. Adding and subtracting are kind of the same thing. I know they seem like opposites, but in terms of sequences, adding and subtracting kind of belong to the same category. All right, so that common difference, right? Remember this, common difference is -6, right? Because we are subtracting 6. If we were adding 6, this would be a positive 6, okay? The first term, right? The f of 1 or the ace of 1, right? The first term is the other key piece of information that we need, and that is 36. So when we build our equation, we're going to say f of n equals common difference times n minus 1 plus whatever the first term is. So this will be 36, okay? So there's our equation. And remember, if you're on a test or you're on a quiz, you might want to test a couple of values. You might want to test 2, 3, 4 and make sure that you're getting the right term values out of your equation, okay? So now we're going to work on the graph. Okay, so remember, these act as ordered pairs. So we're going to go 1 comma 36. So I'm going to go right 1, I'm going to go up to 36, I'm going to plot a point. All right, and we go to 230, 324, 418, and we see that linear pattern forming, right? And then 512, there we go. And then we would not connect the dots here. Okay, so remember, for a sequence, we do not connect the dots. So this is a good graph right here. So we have our table, we have our graph, we have our equation, we've got our 3 representations. Now let's look at this one. This one says use your equation to find the 17th term. Remember in the warm-up I had said something crazy like find the 30th term, and it would have been really annoying to continue our sequence all the way to the 30th term. Well, now we have a tool that can help us out to find that term quickly. All right, so if I want to find the 17th term, I go to my equation, right? They want us to use n equals 17. That's what they're telling us here. So we're going to say f of 17 equals, and we're going to do -6 times 17 minus 1, right? Because the n has to be replaced with a 17, plus 36. Okay? And we can just do some quick math here, right? 17 minus 1 is 16, so we've got -6 times 16 plus 36. And at this point, I would go to my calculator, which I'm grabbing right now. You can't see me, but I'm doing it. So -6 times 16 plus 36. And I got -60. Okay, so without having to list out every single term value, I can tell you that the 17th term is going to be -60 using our equation rather than listing them all out. So it's a lot quicker. And you can kind of see where this is going. If we notice something in nature or if we're doing an experiment or something of that nature, we're collecting data and we notice this pattern, we can make predictions about what's going to happen in the future. And that's one of the great powers of mathematics, is to be able to make predictions. Okay, so we're trying to peer into the future when we look at those really big terms. All right, so let's go and do one more here. So again, here's our sequence, 4, 8, 16. Okay, so hopefully you identified the pattern here. This is, again, multiplying by 2, so we've seen that pattern quite a bit. So if we're multiplying by 2, then we know that 16 times 2 would give us 32, and 32 times 2 would give us 64. Okay, so there's us continuing the sequence. Now, the first term, 4, right? We can see that. The second term is going to be 8. The third term is 16. And the fourth term, we found that one already, was 32. The fifth term will be 64. And if we continue it one more time, 64 times 2 is going to be 128. Okay, so remember, this one is multiplying by 2. Multiplying. It's not adding. It's not subtracting. It's multiplying. Okay, so that's different. That means that our equation is going to look like this. Remember, the blueprint for a multiplying sequence, right, is the first term, a sub 1, times b, the common ratio, raised to the n minus 1. This is how our equation is going to look. Okay, so I'm going to identify a sub 1. It's 4. It's the first term of the sequence. B is the number that we're multiplying by. That's 2. Okay, so those are the only two things I need to build this equation. So I'm going to say f of n equals a sub 1 was 4 times b, that's what we're multiplying by, it's 2. So 4 times 2, but the 2 is going to be raised to the n minus 1. There's our equation. Okay, so we got our table, we got our equation. Let's go ahead and do our graph. So we're going to go 1, 4, 2, 8, 3, and 16. And there is our shape, right? And again, it doesn't look like it's making a line, so there is a difference between the shape that an adding sequence is going to make versus a multiplying sequence. All right, let's get this last question here. Use your equation to find the 12th term of the sequence, right? So they're telling us n equals 12 here. So we're going to do f of 12, which means we're going to go into our equation, find n, replace it with 12. So we've got 4 times 2 to the 12 minus 1 power. Okay, so again, this is where I would go to my calculator. Before you do this multiplication, and this is a common error that a lot of students will make, you need to do the exponent first. Okay, so this is going to be 4 times 2 to the 11th power. You must do this first. 2 to the 11th goes first. The result of that gets multiplied by 4. Okay, so let me write this out. We're going to get 4 times, and then I'll write out 2 to the 11th. So you get 2048. Okay, so now we multiply by 4, and we get 8,192. Okay, so the 12th term of the sequence, right, without having to write them all out, I can tell you is going to be 8,192. All right, guys, that's it for today. Make sure you give the homework problems a try on MyOpenMath. Practice this. Get used to writing those equations. Get used to reading that notation. and you guys will be pretty well set up for lesson 2. All right, if you have any questions whatsoever, make sure you send me an email or a message in My Open Math. All right, guys, have a great day. Good luck in quarantine.